This session is a roundtable discussion on the session called Engineering Design or Design Engineering. So in no particular order, I have Kerry Kirwan, Deputy Head of Materials and Manufacturing and Strategic Director of the International Doctorate Centre at Warwick Manufacturing Group, University of Warwick. Next to my right is Dr. Natasha McCarthy, Head of Policy, Royal Academy of Engineering, author, Engineering, A Beginner's Guide, member, Forum for Philosophy, Engineering and Technology Steering Committee. To my left is Kevin McCullagh, founder of Plan, visiting fellow, Northumbria University, and an ex-engineering graduate, even apprentice, if I remember rightly. And then to my right is Dr. Paul Reeves, Principal Software Developer, Dassault Systèmes SolidWorks R&D, former Senior Researcher, International Automotive Research Centre, University of Warwick. And finally, far left is Andy Richardson, Head of Simulation, Jaguar Land Rover, Product Development. Today, I think we're witnessing quite a number of very interesting technologies, advances in engineering and science. So a guy last week, or this week rather, came up on a balloon, fell out of the sky, 24 miles up, and broke numerous world records, hit a speed of Mach 1.24. I think you could probably argue the guy has quite big cojones to do something like that. But what was really amazing to me about that was that not only his bravado, risk-taking nature, which I think is important, but also the science, design, and engineering that got him up there in the first place. For example, the balloon he went up in had a capacity of 30 million cubic feet, rather big, and a thickness, as described, of a dry cleaner bag. So he's either a lunatic or he's got very good faith and trust in that amazing science and technology and engineering to put it up there in the first place. We've also had the Mars rover, currently, as the BBC News describes it, as eating dirt in Mars, obviously analysing the planet, and obviously will, I'm sure, in many ways be of a great benefit to us in the long term. And again, a marvel of science and engineering and design to get that thing up there and to control it from so far away with such a big time delay lag. And then we've also got another example of many, the Bloodhound car that you might be aware of, which is currently in preparation to try and beat the 1,000-mile-per-hour speed limit. Well, not really a limit, but record. And the real thing about that car that excites me, apart from it's got 3 engines, a rocket engine, a jet engine, and my favourite bit, it has a Formula 1 engine. I don't know if you know the story of why it has a Formula 1 engine, because it needs that power to push enough propellant at such pressure into the rocket to get it going. So quite an amazing marvel of technology and engineering. You might have seen it on the news last week, firing up. And then we've got other things, such as the Virgin Galactic suborbital planned space flights from Mr. Branson, and other areas such as power boats, all kinds of stuff that, to me, as a casual observer, are pretty darn exciting. And I'm very much looking forward to how we can make use of all this stuff, which is really where I come to the contention of what I see this discussion as today, is that with all this fantastic stuff going on around us with high-end science and technology and engineering, why is it if we look out the window or remember how we got here today, that we've probably been relying on transport in some form or other that hasn't really changed in real nature or essence for the last 50 to even 100 years. So we're still reliant on cars that are, the previous century's technology. And we have planes that, although have bigger, wider seats, and you can listen to your TV and radio, whatever, and maybe even one day soon talk on your mobile phone, they haven't particularly changed that much in terms of the speed of travel. Of course, their engines are more efficient, but isn't there something more we can gain from all this advance in science and technology that is purportedly all around us, that perhaps we're suffering from a lack of it right now? So, that's really where I see this discussion is about today, where, how can we bridge this gap? And how can we make it more of an impact on our lives and our everyday experience? Well, I think that if you look around you, there is obviously significant need for improvement in, for example, infrastructure. Railways, roads and so on are pretty decrepit in many ways and are crying out for improvement. So, maybe perhaps the most advanced piece of British, at least, science and engineering that we might, some of us own, is a Hoover. You know, is that the extent of how we can really sort of make use and experience a lot of this stuff? So for me, you know, what has happened to the sort of sense of wonder, capability and demand? And equally, is the other aspect to this discussion that we need to be cognizant of is that perhaps ambition is the wrong thing to really demand at all, that in fact we need to behave more responsibly, and therefore perhaps one of the reasons why engineering in the real world for you and me is not making such a big song and dance for itself is because they accept the kind of more responsible agenda that we need to be very careful of resources and so on and so forth. So that's my sort of kind of opening gambit or context, shall we say, to the panel. So, you know, panel, do you agree that there is a disconnect between, you know, the capability of science and engineering and technology and design and what we experience in the everyday world today? Who wants to start?
Yeah, I mean, there is a disconnect, and the reason for that is because you can talk about sort of Bloodhound as, you know, this amazing piece of technology that's going to break speed records and so on, but you're not going to put it on the M6 and get to Scotland in half an hour without a lot of work that is, you know, in addition to the kind of technical work that gets the car in the first place. So I think your point about infrastructure is key. You're not, when we do engineering, we're engineering for a complicated social technical system. It's not about creating one thing that works really well. It's creating something that works with the structures we've got already for people who have certain needs and interests, for people who have their own technologies that they're using in the infrastructure, and for people with worries and fears and concerns and so on. So I think the issue is technology in a bubble is somewhat easy. Technology in the real world is really, really difficult. And I think that's why we have the disconnect.
Okay. Who wants to come back on that or make another point? Kevin?
Yeah, picking up on a point that was made in the first session of this stream this morning, I think another reason for a disconnect is the lack of scale we've got to turn this sort of quite high-end boutique innovation just bleeding into the start of innovation to really bring it to market. You need lots and lots of skills to rapidly value engineer things down to a cost where it can really make an impact. And I think that to a certain extent, in the UK anyway, we've lost a lot of that ability to scale invention, and we're too reliant on high-end sort of boutique kind of work.
I was going to come back actually on the sort of car analogy and the fact that it hasn't changed very much for 100 years. And to some extent I agree. Of course, the part of the issue with cars is that you want to carry passengers around. So, of course, the package of cars tends to stay somewhat similar. And we tend to have four wheels in the corners, and actually we have to have an engine to get it around. But actually, particularly in the last 10 years, the technology that is available in the average passenger car has grown enormously. I mean, there are many, many sophisticated systems in vehicles today. I mean, you think about when we first had the first airbags, we have traction control to aid the traction. We have sophisticated braking systems. Then when you bring it right up to date, then we have very sophisticated infotainment systems and navigation systems, brake-by-wire, the ability to detect that you are about to potentially hit a pedestrian and fire an airbag to protect that pedestrian. So I guess the point I was going to sort of come to is that the car may not look as though it's changed very much, but actually it has changed enormously, and I think that this is a similar story in many of the other sectors. Now, is it enough? No. I mean, I think there is a lot more that we can do, no question about that, and there's a lot more that we can do to connect the technology innovation that we're getting up through the youngsters in the universities out into industry, and that's the secret. It's really about bringing that innovation and actually being able to deploy it into real-world products that have meaning to the customers. And I think that's where the point about education and also the point about scalability really starts to play a part.
Just picking up on one thing you talked about there, for me there's always a sort of an interesting kind of sort of balance here between innovation, which is very sort of kind of pushing ahead with new ideas that perhaps the customer isn't particularly asking for, and whereas, you know, the other side, which is about refining what we already have. And I suppose one thing to kind of push out here is that, is there really a need for us to kind of push ahead with groundbreaking ideas and technologies in the first place? Or actually, what we have right now, is it enough for us to continue to kind of make more incremental improvements? So that's kind of something I want to kind of throw out anyway for people to respond to when you get a chance. So
I do think that had in the past, it's quite often people would come up with new products that people didn't realise they had needs for. There's millions of examples, but so that's one point. So I still would like to believe we still live in an age where it's possible for clever people to just come up with ideas that people hadn't ever thought of, and that's kind of what excites me to sort of remain in the sort of area, at least, of engineering. On Andy's point, and I almost always ask this when I see someone from Jaguar and Land Rover, I fully agree that Jaguars, the great cars, there's all the infotainment stuff, and I think you mentioned we've got braking systems, we've got brake by wire, control by wire. I mean, it sounds like almost a trite, trivial question, but the thing to me, the main thing about a car is that it's an advance over walking in a horse, and Jaguars especially can travel it completely safely at more than 70 miles an hour, but we're sort of, I never hear anyone really, especially car manufacturers, who probably understand this even more. There's no real discussion of cars, if that is the form of transport that's going to continue travelling faster. Now, I know there's loads of knock-on here with fuel consumption and infrastructure, etc., but I suppose my point is the primary purpose of a car is to go from A to B, and there doesn't seem to be any anywhere, apart from maybe me, questioning of why haven't we got an infrastructure that supports cars travelling at, say, 120 miles an hour or something like that. So I'm just interested if anyone from the industry ever thinks about those things in any shape or form.
Well, I guess perhaps I should come back to that specific point, and I think the technology that you would need to travel at such high speeds is gradually emerging, and I think some of the technologies that we're developing today, which operate at more modest speeds, things like the advanced cruise control, which can detect how close you are behind the car in front when you're travelling on the motorway, and actually it will, if it detects a vehicle that you're approaching, it will detect that gap and will actually then start to slow your car down so that it maintains a gap. Now, if you take that to the next level, where it can really sort of lock into travelling at a similar speed, then it means that you could then increase the average speeds. So that technology is not a million miles away. Now, of course, you've got to be absolutely certain that it's going to work. So I think that there's an evolution of that technology to get to the point where we really can rely on it. So in terms of infrastructure, I don't think that it necessarily needs to demand a massive investment in infrastructure, but it does require a maturation of the technology to be able to do that safely. But I think that will come. I've no question that will come in the relatively near future.
I believe that there is huge opportunities for innovation still going on, and we are still seeing it. But there's this, you've got to, as Natasha said, you've got to get into a bit of context. Sometimes it can occur in a bubble, but people generally are one of the key issues with adopting new technology. That, you know, we're seeing driverless cars now. I think Google got permission last week to launch a fleet of driverless cars. I don't know how many people would be that happy with having a driverless car. But, you know, if you're on a plane, if it's on autopilot or the pilot's flying it, which one do you prefer, and things like that. So there's that issue, but there's also just, as I said, you know, there's an issue of time and cost and everything. So the examples you gave are very much what we would call one-off sort of, you know, real-life prototypes almost. And there is a lag between it hitting the mainstream, and that will be down to consumer demand ultimately.
Okay. I mean, actually, I want to ask you a question as well, Kevin, in terms of what you sort of said before about scale, because one of the interesting things that's coming out at the moment with sort of the discussion around engineering is this other side of it, which is about the kind of the amateur, the small scale, the kind of the maker movement, if you like, as a very interesting way round some of these big infrastructural, you know, capital-intensive sort of problems to kind of kick-start some of this stuff, where we are seeing lots of other kind of disruptive, sort of smaller ideas emerge to maybe kind of get things going in a faster sort of way. I mean, how do you kind of respond to that, Kevin, and others, of course? Do you think it's positive? Is that one of the ways to start to get things happening more quickly?
Yeah, I think I've kind of slightly seen the maker movement in a slightly different context than solving infrastructure problems, I have to say. But I think one thing that was slightly picked up on, again, in previous debates, is that I think there's a need to sort of re-enchant manufacturing. I think that there's lots of smart people aren't going into engineering. Lots of I think a recent report came out that even just to keep engineering where it is right now, we're 10,000 graduates a year short or something like that. Since the economic crash, there has been more of an emphasis on rebalancing. So from the top, there's been an emphasis on more real engineering rather than financial engineering, as Mandelson put it. And then from below, there's a lot of excitement bubbling up around technologies such as 3D printing. However, I think that we need, there's still a disconnect there, because I think there's it's quite a lot of hobbyist activity going on. I think it can play an important educational role in getting a new generation of kids. I know when I was at school, I got my hands on a little CNC miller when I was 15 or 16. So I think that has it has a role to play in like I say, re-enchanting manufacturing with a new generation. But in of itself, it doesn't get anywhere near the kind of scale we need to make a real impact.
Who else kind of agrees with that? I mean, is that the right sort of emphasis, that the sort of 3D printing, the sort of amateur is and will remain more of a kind of a hobbyist sort of activity? Kerry?
I mean, I wouldn't call them amateurs. Individuals are historically always the ones that come up with the bright ideas, not big institutions. Big institutions like Jaguar Land Rover and things like that have a nasty habit of actually disincentivizing innovation because of the risk associated with it and everything else. Individuals and small SMEs and things like that, they can take risks that large organisations won't. So yes, there is a groundswell of that going on. I can't remember the exact percentage breakdown, but I think we've something like a 70% of our manufacturing base is actually small, medium-sized enterprises, but they don't contribute huge volumes of wealth.
Are you saying, though, that with regard to sort of large-scale R&D, that era is over?
If you have too many, high-value manufacturing things going on, they do tend to be located within big organisations who deliver very good products, but they, again, take a lot longer. They're not as quick to react as what the market needs.
I think the additive manufacturing issue is a really interesting one, because there's a range of different impacts and benefits it can have. So one of them we're talking about is the resurgence of manufacturing and a new way of doing manufacturing in the UK. Another thing is just the way we can make things that are far more complicated and specific than we've been able to make with normal manufacturing methods. But one thing I'm really quite interested in is the sort of propensity to be manufacturing with less waste, and also the possibility of manufacturing things like spare parts for things that break down frequently, and manufacturing more locally, so you can manufacture with a much sort of smaller distribution network, and therefore have a manufacturing system which uses less resource and uses less energy. Because I want to go back to something you said a few points ago. Do we need big innovation right now? And my feeling is that at the moment, actually, what we want is for everything to stay exactly the same. Because the problem we have is that we do have to reduce carbon emissions. We do have to use less resources. We do have to use less energy, because at the moment, most energy production types are high carbon. And so the challenge is really, how do we carry on living the way we do right now? And I go to meetings where people say, well, we have to stop living how we do now. We need to make people change their behaviour. But the kind of behaviour change we require is for people to turn their thermostats down to 12 in their house, to keep their phones for 20 years, to stop driving everywhere, to shower twice a week. And that's just not going to happen. So the question is, how do we maintain our lifestyle as it is now? And I think a lot of that is about making things more and more efficient. And maybe, additive manufacturing is one aspect of making things more efficient in terms of both resources and energy. And that is the kind of innovation we need at the moment. And it's actually really exciting. in the same way that Bloodhound is exciting. It's just to a different end.
On the 3D printing additive manufacturing, I have got one slight concern to it. If you think about it in a certain way, it's actually quite risk averse insofar as, yes, they're flexible. You don't need to invest in large amounts of serious machine tools that cost millions. It tends to fill niches rather than. I can't say for sure what's going to happen, but at the moment, the way it's talked about, I think it's Chris Anderson wrote a book recently about it. His analogy is with the internet, where you've got lots of small companies, entrepreneurs, generally West Coast type people, setting up small businesses that fill niches. Now, I'm sure that in the long run, additive manufacturing will produce something that is a step change, etc., whatever, but that's just maybe my slight concern about it. On Kerry's point, I don't believe it's always the case that big institutions can't produce innovative products, innovative ideas. I mean, looking in the past, we had the classic example is, say, AT&T, with their research labs produced C++. I think they produced the lasers, maybe the transistors, I'm not sure. But the point is, they may have been large organisations, but they were still able to organise and spend on R&D. And in the long term, things that they hadn't necessarily set off to produce just come out of it, and we enjoy the benefits of all those things now. So I think what maybe has happened, maybe since the 1990s, is that a lot of companies, lot of large, nominally manufacturing type companies have done is the influence of sort of financializations come into it, where say marketing and branding is risen, possibly at the expense of R&D. And also R&D's been, in those big organisations, has been forced to in some ways show that it can cover its costs and things like that. And I'm not saying you can go back to what there was in the past, but I think it's worth bearing in mind, or at least think of the possibility that big institutions don't always have to kill innovation.
Yeah, two things around large-scale R&D. Take an example of driverless cars, which for me is the genuine big next innovation in automotive. I would personally put my money on Google or Toyota, fairly big companies, being real big players in that next big leap, rather than SMEs. On the additive manufacturing point, I agree. I think it's not a new manufacturing revolution. I think it'll expand into lots of new niches. But when it comes to saving resources through distributed manufacturing, so you have all these printers dotted around everywhere, and you can make everything locally. I wouldn't underestimate just how efficient global supply chains are, and you've still got to get all the materials and distributed to all these different machines. And I think it's when you run the numbers on stuff like that, I don't think a lot of the time it'll work.
Okay, Kerry, do you want to come back to some of the points?
Yeah, I mean,
about big is bad, or
I didn't say big companies don't innovate. What I said was the majority of innovation actually comes from individuals and SMEs. If you just look statistically, so big companies do innovate, but they are more risk averse as financials come into it. With regards to sort of ALM, it was sort of I'm not sure it's not just this year's fad actually, or current fad at the moment, because it's been around 20 years. It's got a good press at the moment, and it could be that something else has good press next month. I'm not convinced with it does get used for very high-end specific applications where you can make things that you can't make via traditional methods. You can get some advantages from it, but whether or not you're going to have one in every house making your household widget, I very much doubt.
I mean, one thing just to sort of defend the point that maybe big is not going to be the way to go in terms of engineering and R&D is that, well, one economy which is really successful at this is the German economy, the sort of German Mittelstand, which is predominantly made up of very small, sort of even family-orientated businesses or SMEs that are very strong because they are not hugely capital-intensive, they're more connected to the kind of global supply chain, and because of that, they're more flexible. So, maybe that's actually the model that the UK, for example, as an economy that's trying to kickstart manufacturing, needs to also adopt. And then when you look at, the actual construction of things like planes, for example, I read in, I think it's the Engineer, the way that the 787 Dreamliner is made up of lots and lots of very small component suppliers. Of course, you've got Rolls-Royce who do the big Trent 1000 engines, but you've also got lots of other companies who do the seats, the compasses, and all kinds of stuff. So, maybe big is no longer necessary anyway. So, Andy, I mean, do you want to keep defending big, or are there other ways to do it?
No, I don't think big needs defending, actually, because I think actually the thing that we would recognise in industry is that it's a balance. I mean, we of course have big research and development projects, and of course at the end of the day it's important that we can deliver product out into the market, and that means that you have to be able to productionise. It has to be viable as a new technology. But in order to get to that new technology, that new viable technology, we have to do a lot of innovation along the way, and some of it might not work. But I think to sort of address the previous point, absolutely, we are working, and any big company, like the aerospace companies as well, has to work with lots of individual smaller suppliers, and also indeed the research sort of elements in universities as well. It's really important that we engage with all of the leading edge technologies out of the universities and with our supply base. The aerospace and the automotive and many of the other big industries, I think, are probably fairly common in this, in that these days we work with a global resource of real leading-edge suppliers as well as small companies. And I think that's the way of the future. It's a balance. It's about striking the right balance. It's not all big. It has to depend on small real innovators as well.
Before we kind of have an audience debate and to challenge what we've been saying so far, I would like to maybe just throw out a couple of things about the perception of engineering and manufacturing, because it seems to me the public is pretty unaware of actually a lot of amazing things that are going on. So maybe you've seen the Evan Davis programme built in Britain, talked about some quite incredible infrastructural engineering challenges. For example, London Electricity, I think it is, spent £1 billion sinking masses of tunnels around London to kind of recable the capital. No one heard about all that, but it's an amazingly sophisticated piece of engineering. And likewise, the engineering that had to take place for the Olympic Games to ever happen, they had to shift all the electricity pylons out the way and therefore had to sink really deep tunnels. And without that, the Olympics would never have happened as it did on time. So, why is it that we are perhaps so bad at selling our expertise as engineers and as designers? Is it just that we are too geeky? There is no public need for it? What's going on?
Can I make a point which perhaps to some extent addresses that issue, which and it comes back to the Bloodhound, actually. We were sort of saying, in a sense, felt the emphasis was, what's the point of Bloodhound? Well, the one, apart from the sort of real exciting kind of challenge of breaking a record and the engineering challenge that faces, and absolutely shouldn't underestimate the real technical challenges in achieving that. But the one thing that absolutely impresses me about that project is the way they've gone about organising it, and that they've involved universities, they've involved suppliers, and absolutely they've involved the schools, and actually getting involved in the programme. And actually, I know that Richard Noble has been doing tours around the schools to really engage people, engage young kids in technology. And I think it's really crucial that we inspire the next generation to be interested in technology. And it's that kind of project that really grabs the headlines and really grabs the interest and emotion that can really sort of get kids excited in the next generation for technology for the future.
The challenge we have are those technologies that aren't the really obvious things, that things that are a little bit invisible. And the big issue is that engineering works when things are just fine. That's when engineering's working its best, when we don't notice that the road's been dug up to lay some electricity cables because it's all been done underground. That's when engineering works really well. So that is the challenge, how to make it visible when success is actually invisibility and a lack of disruption.
But can I kind of pose a question back to you in the panel as well, is that perhaps the need to be more responsible, resource-wise, is one of the reasons why engineering has struggled to make great inroads in the public perception, because we've always been, or rather engineers have always felt they've had to kind of hold themselves back rather than kind of pushing forward new extravagant ideas.
I think that's a good point, actually. But one of the things that is strange, and I think maybe times will change, is, as I say, you know, the fast car is a stereotype of engineering that lots of people understand and lots of people are really enthusiastic about it. But you get as many kids at school who are excited about fast cars as you do who are excited about, you know, saving the planet and environmental issues and helping other people. But the people who are interested in those things don't always realise that there's a massive engineering component to that, and that's what we really need to work on. Getting to the people who want to make sort of changes to our way of living and changes to our planet that are positive and are less obvious than sort of making really, really fast cars.
I think it's really important that we do have these high-profile projects that we can enthuse about. But I think one of the things that engineers haven't done so well in the same way that, say, scientists have, I think, you know, we need more sort of Brian Coxes, if you like, for engineering, who can really not only enthuse about the detail of the subject, but also engage in wider debates and really bring that sense of wonder and that can-do attitude that engineers have to wider society. And that's my problem with the sustainability argument, because that does start to bring a narrative to what engineering can do. But it tends to be quite a conservative, let's not progress maybe as fast as we could kind of attitude. And I think there's so many problems that society would need to get behind engineers to solve, that we need to be a bit more inspiring than the sustainability agenda.
We did fast cars with sustainability. I headed a team that made the world's first Formula 3 racing car, which essentially was a Formula 3 racing car that we made completely from recycled, reused, natural waste materials, and it outperforms a conventional F3 car in every sense. So you can combine the two, and the purpose of it was to get away from this sort of boring science and engineering into something that the public wanted to actually pay attention to and have a look at. And it does a great job for kids and getting kids involved. And we've got to realise we've had 20-odd years of degradation of the engineering recognition, I guess, and so engineering hasn't been sexy and interesting till the last sort of 3, 4, 5 years. We're not going to overcome that overnight. So things like Bloodhound are great if they get people back into the workshops, into the labs and things like that. As to whether sustainability, I mean, it's whatever engages people, in my opinion. That's really what we need to do, is get people engaged. So yeah, I mean, Brian's a great example, but we don't need loads of Brian Coxes. We need some different people than Brian. But you know, as I say, press and engineers and scientists have been historically quite bad engaging with the public. It was always something, you know, indeed, you know, quite often it's frowned upon, actually, you know, scientists and engineers going out and talking to Joe Public until the last few years. Just that was something that only the sort of the poorer academics did. We are seeing that changing now, which is good.
Isn't there also a danger that engineers, perhaps like Dyson, can be a very easy sort of token to sort of pin your badge to as a politician, perhaps, as well? So that, you know, perhaps we need more of a sort of substantial sort of debate.
Yeah, no, we need politicians to stop coming up with fads. You know, we need it real, and you know, this resurgence in manufacturing. I mean, it's nowhere near there yet. It may have started, but it's not finished. Okay. There is a risk that it just dies again.
Hands up if you recognise that at all. Okay? Yeah, okay, that's not bad. I mean, to me, this actually bridges the gap between engineering bubble-type stuff and something that really could be done. I mean, this, briefly, it's a single-stage rocket, effectively, that can, and this, to me, is the key thing about it. It's capable, if it all worked or whatever, of decreasing the cost of getting matter into space by a factor of 10. Now, that is quite an impressive thing. When I'm looking for ambitious things to inspire young people or whatever, I'm looking at things like that, because I see it as being practical. It can be done. As I say, it's based on 20th century technology, developed a bit. But I would see those things as being inspiring. And to connect it to the idea of everything being the same, I think this is something that could actually add to our infrastructure, you know, and not only add to our infrastructure, but it could also allow other technologies to develop, which may solve any of the problems that, as you say, people are conscious of and fearful of. But we have to start off with the idea that we can actually do it.
But Natasha, are you against open-ended sort of research and R&D like that?
No, I'm not against it, no, absolutely. My point about things staying the same is about, well, what are our priorities right now? And right now it's a relatively short period of time. So no, I'm not saying we should not think about anything for the future. What's interesting about this piece of technology, and maybe slightly different to Bloodhound, is, I think I read your article, and one of the purposes is for delivery of satellites into space, and it's something that's a reusable vehicle for doing that. And that is, satellites are a massive part of our infrastructure. We rely on satellite technology, and we need satellites to be working properly for things like GPS and so on, and lots of things like emergency services are dependent on it. So that, to me, that has a big part in maintaining the infrastructure we have now that is giving us essential services. And it's very interesting in that it's actually something that is sort of sustainable in its own way, because it's about something that's reusable. So no, I'm not against Skylon.
We need these big headline projects because they do two things. They capture the imagination, then they engage the next generation of young engineers and technologists. But at the same time, they do push the boundaries in terms of technology. And whilst you might think, what's the relevance of that to the everyday sort of person in the street? But these technologies do filter through. They do drive new innovation, which actually drives new capability in the engineering domain. And those things can then have, sometimes unintended, beneficial sort of spin-offs. So I think that sometimes you need these big headline projects to really drive the technology forward, and then you sort of you see many consequential benefits that come from that afterwards.
I'm a little chary about what it is that we're trying to inspire people to do once they've been inspired by Bloodhound. It seems to me that the answer to that question is always, well, you inspire children, you send them off to university, they become engineers, and then they go and work for large or small, medium, sized enterprises, they become engineers. That's a very long payback. And actually, the reason that people get so excited about the democratization of, whether it be 3D printers or the democratization of design and all these extraordinary design tools that we now have sitting on our desks, is that we can now make things for ourselves. We don't have to wait until we've gone to university and then, start in an engineering job and then work for a company and, and all these things. Over a generation span, is that we can jump straight into building the things that we want to build for ourselves. The problem that we hit is not that nobody has designed a 3D printer that works brilliantly, but that we don't have access to any machine tools. Because it's insane for an amateur engineer, a hobbyist, the beginnings of an entrepreneur wanting to make the prototype for that first business, it's insane for that person to own all those machine tools themselves. So if you want to build, whether it be your own, you have a design for a new thing that you want to customize your TV so that it fits in with your decor, or whether you want to build the prototype that starts your new business, what you have to do is you have to go to a whole bunch of little engineering firms who deal with one process. You need to deal with the welders, you need to deal with the plastics people, you need to deal with the, the upholsterers and, whatever it is. Just dozens and dozens and dozens of little processes, all of which happen elsewhere and which are not tied together. If I want to go to the gym, if I want to work on my body, I can go to the gym. There's a guy who owns lots of body-related machine tools and a whole bunch of personal trainers who'll help me to learn how to use them. That doesn't exist for engineering. I can't go to a public workshop and say, I'd like to use your CNC milling machine, I'd like to use your lathe, your injection molding machines, and so on.
All right. Point well made.
I wonder if engineers need to make a more bullish case about the potential that they have to transform the world, basically. So there's been a lot of discussion about transport, and I wonder if the problem is not so much engineering, but there's a prior argument there about individual personal mobility at a societal level where people are sceptical of that. And you can see that right from the top down, looking at TfL, their answer to the underground is to give people maps, walking maps. So they're essentially saying, have you considered walking rather than taking a tube? So there's a definite skepticism there towards individual mobility. So I wonder, what's the relationship there between engineers and their potential to really transform things and a less kind of pragmatic case than whatever works? Should they be more, bold about saying we can really transform things? And a second subsidiary question about 3D printing, and I'm open to persuasion on this, but is that not the kind of focus and obsession with 3D printing, is that not a manifestation of the same thing, an obsession with kind of small, local celebration of things which aren't transformative, but are just, local?
Not so much questions, really, as comments.
Good, I like comments too.
And so things may improve now that we've had some questions. But it's been terribly motorcar-based, really so motorcar-based. That's what, yeah, I know. I was so pleased you brought that up because I had come across that. It's really great. But it's still very much about things that move and go boom, boom. And so little response to what Natasha said about sustainability. Okay. I really don't think any of you have been listening. And my experience as quite an elderly person in this room is in trying to get volunteers to do things for the things that a lot of things I'm interested in, is what young people are interested in nowadays is sustainability. They're out there in the transition towns and those sorts of organisations. They're interested in the environment. And I think there's a lot more seriousness that you could be taking of what Natasha is saying.
Yeah, I'd like to come back to this this issue around what deals with sustainability as well, but a bigger picture, long-term vision for society. And I think what engineers have got to get involved in my opinion, is more than just public awareness, bigging up interesting projects, but also engage in higher level debates with politicians and what have you about how the world could be different. We're living in a society today that doesn't have a vision of the future. It has some notion of perpetuating the current state of affairs through recycling or something. And if you take this notion that we've got to just engage or relate with the public, you end up taking a lead from kids who think that sustainability is the only game in town. What we need to do, I'm a lot more informed than a kid, and I think most engineers are, and I think we should be setting the agenda and just showing what we're capable of, the problems that are capable of being solved, and get out of this stasis that sustainability encourages.
As far as the sort of public perception thing is concerned, we keep going on about it, but to me, ultimately, I think that the big projects, something like that, is something that people could get interested in. They'd be interested in friends who did it, whatever. But what it takes, and it's what a lot of young people aren't prepared necessarily to do nowadays, is it takes years of learning maths, physics, learning English and writing better than I can do. But basically, it takes a long, dedicated period. And I think on big projects like that, people would be prepared to dedicate a significant part of their life to working on something like that. I believe that a lot of the things around sustainability, limited resources, etc., provide a backdrop of anxiety, which I think is unfounded. I'm a great believer in not just technology, but society developing in general, to be able to resolve any of the problems that we've had. I mean, in the past, Bazalgette managed to basically eliminate all of the problems that existed through poor water, sanitation, etc., etc. And he did it not by changing people's behaviour, he did it by using whatever technology was around at the time, statistics, etc., and he solved the problem, and as you pointed out, Natasha, now it's invisible, no one cares about it. Now, I'm hoping in 100 years no one will care about the issues of running out of oil, CO2 emission. I think an issue with the sustainability and the CO2 emissions thing is it's myopic just to concentrate on the emissions of CO2. There's lots of ways that issues with, I believe global warming is likely to happen. I'm not someone who says it's not going to happen, but there's more ways there's more than one way of dealing with that problem if it is a problem. And engineering, surely, on a big scale, is something that is going to help that.
Again, responding to the lady there, you're absolutely right. Most of my exciting work in sustainability has got nothing to do with cars. So we're doing things like, the stuff that gets me really excited. We're cleaning up. We've got some projects looking at cleaning up polluted land and then turning the stuff we remove actually into things like cancer treatments and things like that. So there's much more exciting stuff out there. It tells a much nicer story than cars. I agree.
Okay.
I think what we're getting down to is, who finds what exciting. Some people find fast cars exciting. Some people find the idea of a factory that is completely closed loop exciting because it's beautiful and efficient. I find that exciting, but maybe we don't all find the same things interesting. But what I thought was interesting in the points made was a lot about the perception of engineering and how engineers sell themselves. And I mean, engineers don't sell themselves. They are basically doing engineering. They don't tend to go out there and sell themselves. But it is important that we do get people to become aware of what engineers do, not just because we want them to become engineers. And the first point that was made was about HS2 and whether we just say, here's a technology, engineers lobby, let's have it, let's do it. It's really nice and inventive, and we can prove ourselves. But we need to have a public debate about that. Engineering is entirely, this is my first point, is entirely enmeshed within society. So one of the purposes for getting people interested in engineering is not to either build fast cars or to create, really sustainable means of energy, but it's to be non-engineers who are informed and aware of the engineering issues that affect them and get involved in debates about them and help make the decisions about what kind of energy we use, what kind of transport infrastructure we invest in the future, and where we focus our efforts, whether that be autonomous vehicles or a whole different way of travelling completely, maybe by foot instead of using the tube. So we need to have more awareness. To a certain extent, though, is it actually the job of the engineer to be engaged in a lot of these ethical, moral questions anyway? Is it rather for everyone else to decide?
I was actually, coming to sort of make a point about that, but I think that what's become apparent to me, even just in the course of this discussion, is that it's not right for engineers to be leading the sort of political debate, if you like. And HS2, I'm not sure really is an engineering and a technical issue. It's more about the politics and the business case behind it rather than the actual technology. But I think that what is apparent is that engineering and technology can really drive the capability to do so many of these different things. I mean, whether it's about putting the next satellite up into space, whether it's about breaking the land speed record, or whether it's about solving the world's environmental problems through engineering. I mean, there's so much work that I think is going on in sustainability, which is about how do we create sustainable energy sources. I mean, wind power, wave power, you mentioned thermal, which I think is geothermal is a really exciting, potentially free source of energy. So these are, I think, these are examples where engineering and technologists are really providing the ability to solve so many different problems for the future, whether they're in the environmental domain or in the sort of exciting fast cars domain. It really needs, it's the same thing, it's still about engineering and technology development.
I've got an interest in engineering in terms of standardised engineering versus non-standardised engineering. By that I mean when you design something, you design it so that it operates as the designer expected, not as the user maybe wants to use it, so therefore it's not flexible. And non-standardised engineering, meaning that it's got flexibility designed into it so that the user can use it for purposes slightly different, slightly modified to what the designer actually expected. And part of this comes from my interest in sustainability and the fact that when you, for example, look at water resource use in Australia, for example, with water shortages, the people have been trying to use, for example, the automatic washing machines in a way that they can conserve the water and use it for what they want to use it for, rather than putting it down the drain, and they're actually having to fight the design of the washing machine in order to do that, in order to use the resource, the water, in a way which allows them to be flexible. So part of what I guess where I'm coming from is that you've got very smart engineering at one end, and then you've got an assumption of a very non-smart user at the other end. And what you seem to be doing is missing out on harnessing the intelligence and the innovation of the user by designing the engineering to be really regulated, really standardised. And I guess it kind of comes into as well where you're generating the interest in engineering. If you've got flexible designs which allow the user to be flexible in the way they use them, then you're going to generate an interest in how you can modify, how can you use it, how can you engineer it. I actually come from New Zealand, and we've got the number 8 wire idea back there where you've got people in their backyards.
Okay.
who do this sort of engineering of a system for themselves to use how they want it to use it. So has anyone got comments about this, thinking about engineering the opposite way, to not design to be standard, but to design to be flexible?
Well, I'm not an engineer, but I work with a lot of engineers who do want to talk to the public. And so the good news is there's lots of Brian Coxes and Bryony Coxes out there who are really good and raring to go. But I think the bad news is that engineering is slightly up against, and I don't think it's as native to engineering at all. I think it's a much wider thing in society, but it's up against the idea that actually we probably shouldn't tinker too much with the world as it is, and we shouldn't interfere with nature, and any big project that humans take on is bound to go wrong and be awful. And I think that is a real atmosphere of dampening the ambition of humanity generally, and certainly of what engineers could do. So I was a bit, and I feel this is a bit unfair in a way to pick up on this specifically, but when Natasha said, well, we have to use less energy because pollution and it's getting more expensive and so on, and my heart sank a little bit because I thought, but if engineers are not going to find us the solutions for us to have limitless, clean, convenient energy to allow us to do what we want to do, then who is? And I know that these things are out there. I mean, nuclear fusion, I know, the joke is that it's always 20 years away, but we are gradually working our way towards getting nuclear fusion. And you look at the flurry of interest in the making petrol out of the air, which is still way off being a practical thing, still at the stage of you put loads more energy in than you get out. But in principle, if you can turn the air into a carbon-based fuel, then there's your carbon cycle solved, because you're only putting out as much carbon as you've put in the first place. And I think you would actually inspire much more people, not just kids, but their parents, their teachers, their aunts and uncles, all the people that can influence them. You'd inspire them much more if engineering would raise its sights a bit and go, okay, well, we all want cheaper gas and electricity for a start. We want lots of energy. We want to be able to do the things we want to do. I really agreed when you said you can't start from the point of changing people's behaviour. If engineers said, well, these are our projects, come on board, be the next generation of fusion engineers, let's have that electricity too cheap to meter that they talked about in the 50s, I think that would actually be something that would inspire people a bit more.
I could go on all afternoon about the very interesting points that have been raised, but I'll restrain myself to 2 points, one about engineering and one about engineers. I mean, I graduated in engineering 56 years ago now. I went into manufacturing industry. The first lesson I learned was the engineer's role in manufacturing was to deliver the goods and services that people required with the minimum use of resources. News. Sustainability is not new. The second point is you get the few Brian Coxes coming forward to explain engineering, but you won't get many of them, because the basic feature of engineering is it's actually very interesting, captivating, all-encompassing captivating. And engineers don't care about talking to people about it. They'd rather do it. And society has to learn to live with that.
If you look at the British numbers, you'll find that industrial waste, office waste, and domestic waste are all in decline, quite rapidly, actually. And I put it to you that if you think that the argument for 3D manufacturing is that it will lower waste, then why have it at all? Because that would lead to even less waste if nobody is allowed to do 3D manufacturing. I think it's a self-defeating argument. Already our friends at The Guardian are worried about the legal implications of 3D manufacturing, even though we haven't even got it yet. It's a canard, actually, that the law has to catch up with technology. In Britain, the law is always ahead of technology, and the engineers are behind it. Just to conclude, somebody at the front there said, engineers are behind the high-speed train project just because it goes at 240 kilometres an hour. They wanted to do that. Where I come from, it should be going at 500 kilometres an hour, if only to leave Totnes, the transition town, faster, really, because I believe it's in the transition back to feudalism. So, this has nothing to do with boys for the toys or toys for the boys. if you go back to Stephenson's rocket, nobody said to him, oh, well, it'll only save 20 minutes, which is the argument against the high-speed train, right? It saved a lot more than 20 minutes, and we all need to save 20 minutes as much as possible. So more, better, faster, still safe, and maglev, please, trains, to get out of Totnes and Birmingham as fast as possible.
I mean, just very quickly on that, if you compare the 100 kilometres of the high-speed HS1 and how long it took to do that, comparing that with the Chinese railway system, they were covering, thousands more miles in so many less years than we've ever taken to do, a mere 100 sort of kilometres, and having to negotiate all the planning and regulation. So for me, it's, there is in the world a lot of technical capability. So why is it that we're so shy about sort of demonstrating that capability and letting the politicians kind of get on with it and to kind of even use it in their own capacity to kind of demonstrate their own political leadership? Seems strange to me.
Yeah, very fast. The point I wanted to make was that you're talking about how you should include more kids in engineering and you should kind of motivate them. I think this is not a real problem. I think this is like an issue that is nice to be done for all sciences, basically, and applied sciences. I think the main problem with engineers is that they are not including other disciplines in their decision-making processes. For example, we have heard comments on sustainability, and well, I think that if you would talk with environmental managers and environmental scientists, you wouldn't have the dilemmas you have on whether technology can solve these problems or not, because it can't. We know that. It has been proven. And I mean, technology in the current way of doing things, you need some radical changes. And furthermore, efficiency gains was never a solution for environmental problems, because you have the rebound effect, which is a social phenomenon, where you have a product more efficient than the previous one being used more, therefore you negate the effect. So I think maybe you should, I don't know what's your opinion on this issue and how much you include other disciplines like social sciences and environmental sciences and other sciences, of course, in your decision-making processes.
I think that was a really excellent point about bringing in other disciplines, and maybe that is a way to ensure that we can better engage with, with the sort of capabilities that are out there and really drive technology and engineering forward in a relevant way. And I think that's the key. We've really got to make it much more relevant to people's everyday life, and I think that may well be a way. And I think obviously combining the engineering bit with the sort of skills and expertise of those other disciplines could be a really key way to achieve that. How we achieve that, I think, is an interesting question, maybe that's something that we should be working on.
Okay, Natasha.
On the idea of non-standardized technologies, I think that is a really exciting area, and I'm quite keen on designing things to be upgraded and to be changed so we can keep using them for longer by making them better as they age, rather than and letting them just decline and then throwing them away and getting new things. And that links to the issue of we need to use less stuff, we need to use less energy. I mean, when I said that, I think I qualified it with because at the moment a lot of energy that we generate is it produces a lot of carbon. But we have got people working on fusion, and when it works, it'll be fantastic and the world will change and we can do what we like, and I can't wait, personally. But at the moment, we need to invest in both things. We need to look at using less energy, making cleaner energy, and having some people looking at this really game-changing technology. I think 3D printing in waste it's not a simple thing. It's not like 3D printing will eliminate waste, end of story. There are different industries with different needs. And there are some industries where it really could change things. So, for example, fabric industry. Currently, a lot of fabric is developed from natural materials that take huge amounts of water to grow. And then when the fabric's made, we chuck away something like 50% of it in cutting it apart. But if we can manufacture really nice quality man-made fabrics, which can be made to the right size and specification, and then can be melted down and remade again, then you really are creating taking a lot of energy out of the system and taking a lot of waste out of the system. So there are areas where it could be world-changing. And to make it world-changing, we do need to engage with other disciplines, and I'm very keen on that, and I personally get engineers to talk to philosophers and ethicists and really get through the hard issues they have to talk to, and talk to other people when they do that.
The example of water and individual water usage. Water is not a problem in terms of resources. We've got enough water. It's investment in water infrastructure that's the problem. and engineers can help solve that. That's just a perspective point of view. I would focus the engineering effort on the water infrastructure, not trying to meddle in people's behaviour. I think in terms of sustainability, tackling climate change, which is probably happening, you know, I'm not a swivel-eyed denier here, but I think one of the ways of dealing with that is adapting to climate change. And geoengineering is one of the ways that we might adapt to that. And I think that's something that engineers should be putting the case for, rather than taking the diktats of politicians who have lost legitimacy with the public in terms of actually changing anything themselves, and instead of focusing on obsessing around changing individual behaviour.
And engineers are definitely engaging more with other disciplines, particularly sort of psychology, philosophy, people like that, for mainly actually to ensure their products are actually accepted, because consumers are odd people, so they like to understand them. In terms of flexibility versus non-flexible engineering, it's a bit like Windows versus Linux, I guess. The problem goes that lots of money gets put into a product development, so companies want to see a return on that, so it makes life a little difficult for people to just start using it however they see fit, and there's also sort of legislative requirements and the threat of being sued if somebody's using something wrong. So it's a great idea, but how practical it is. I mean, there was a sort of drive towards open source engineering a few years ago that I don't know if it's still ongoing, but I certainly haven't really seen a great deal of it in real life recently. There's the Raspberry Pi, of course, which is a nice little example, but I can't think of anything else that's emanated. Most of it tends to be fixed, and you know, even down to the car engines now. Very few people can actually get their hands dirty and do anything with them because they're so complex, or even just locked away underneath a plastic cover sort of thing.
Sorry, I've still got a bit of idea, and I know it's almost a comment in passing, but with children being innovative, because I think it actually does a disservice to adults, especially adults that have spent years learning a science or an engineering, maths, physics, whatever, who then actually work in a research lab for years and years to actually understand their subject inside out. So, yes, children may come up with some clever ideas that haven't been thought of, but I don't think it even compares with what adults actually do in the real world. Maybe engineers should be better at actually passing on to advertising the fact they actually do that. I don't think there should be a special case. To me, an engineer is just a citizen the same as anyone else. I don't think engineers should be trying to politicise themselves that much as a group, as it were. One thing that is unique to engineering, even more so than compared to, say, science, is basically, fundamentally, we're talking about mankind's, humankind's relationship with nature. I'm just wondering if things have changed maybe over the last 30, 40 years. When you think of the big engineering things that have occurred, like, you know, trains, even bridges, cars, etc., generally they've in a good way, they've done something to actually dominate nature or to change nature or to harness nature. One of the problems I have with sustainability, I don't have a problem with the efficiency side. Engineering should be efficient, but I do have a problem where it's now seen that man should maybe bend and adapt to nature rather than working out if there are problems that have been caused by the way we have a relationship with nature, if there's not ways that we can then transcend that problem through technology, through the way we organise.
A lot of you have been talking about trying to sell engineering to the younger generation, to get more people involved in it, to get more innovative ideas and things. And I think I'm part of this sort of demographic that you're talking about. And, I mean, from what I've seen, this whole demographic, a large selling point of it is, in fact, the fact that engineering is so versatile. It's very linked to other things. I mean, I personally originally wanted to be a doctor until I realised that I'd prefer the idea of fixing machines to fixing people. But a lot of my friends who are interested in it like the fact that there are so many aspects of it and that it's so linked to political things, it's very ethically linked, and it's so mixed into other subjects. Even though it's very technologically interesting, it also has a massive social aspect, and I think that's one of the main selling points for a younger generation. So I think it should be emphasised. Thank you.
I'm here out of interest. I have nothing to do with engineering, except I did service my car a long time ago. And I'm I'm not asking this question, but how does a motorcycle go around a corner? But I want a question on sustainability, because it seems to me that the person here who wanted to know how he, as an entrepreneur, could get all the devices necessary so that he could make his gadget, can't he Google it, press the right buttons, get it produced, and it's completely work-free. So when you talk about sustainability, do we get rid of work? Because it seems very dangerous to me that the machines are going to do everything.
I too am not an engineer. One thing that has struck me hearing the panel talk is somehow, if you are the avant-garde of engineering, is your sort of somewhat lack of confidence in engineering and its role. It seems to me that engineering has two roles. It can solve my problems, and one of the problems we're facing at the moment is sustainability and global warming, etc. Just go solve it. Tell me when you've got the solution. I don't want to know about that. What I do want to know about is things like HS2, and I want you to say, I can get you from here to Birmingham at 3 times the speed you can go now. I'm going to build it. If you build it, they will come.
Martyn provided some very inspiring contemporary visions of the future from Virgin One and so on at the start of the session. I'm interested in what each of the panellists, what inspires them, what visions inspire them to do what they do in the way that perhaps science fiction might have inspired a previous generation of engineers and designers.
Could I ask the engineers for more Moore's law, please? Because the internal combustion engine has an energy conversion ratio of approximately 30%. The electrical grid system, from the generation of electricity to conversion of energy, has an energy conversion ratio of approximately 30%. These percentages haven't changed.
A lot of the conversations focus very much on the UK and the West. I'm just thinking things are moving east, and I'm just wondering if the panel have any comment on that and how that might change innovation.
Good point to finish on. So, panel, I'd like you to sum up in 1 minute or less, and obviously a bit of a challenge. So, who's going to go first?
On that last question then, as things move east, one of the things that I am inspired by, which kind of ties in with almost the thing at the back, basically, yes, we've got huge numbers of people in the East, in Africa, South America, wherever, over the whole world. Generally, people are actually seen as a problem. They're seen as consumers, produce waste, need feeding, etc. But I think the other side of that we should be looking at is there's a huge number of brains there of people that are once their material problems are sorted out, i.e. we can produce enough food, we can produce enough roads, infrastructure, etc., etc., the number of brains that will be around to solve any of the problems that we now seem to have in a kind of semi-anxious age, which leads to things like sustainable thinking, etc., which will have a much greater raw material around to actually be able to solve any of the problems that are thrown about it. So I see that what's going on in the East is being really exciting, and I hope it expands to the rest of the world.
So I'll answer with what inspires me. And I'm not an engineer, but I talk to a lot of engineers, and what inspires me is the fact that engineering has the capacity to solve lots of serious problems at the moment, whether that's the problem of delivering our lifestyle with less waste and less carbon, or whether it's about creating new medical implants and devices that are really going to help people who've got long-term illnesses. And I think that it just shows how closely embedded engineering is in society and society's needs and problems, and so we need to keep working with society, with other disciplines, to try and address those issues.
I'll go for what inspires me as well. It's somebody else's vision that really inspired me recently. It was the Astro Teller, works at Google. He was talking about his idea of moonshot thinking, and there were 3 elements of moonshot thinking. He said, well, we want to tackle problems that if we're solved will make a serious impact on humanity. The second feature was that the solution should sound like it came out of a sci-fi movie. And the third was that it should really be worth putting a massive investment into building a team to crack the problem. And the example he gave was the work that they're doing on driverless cars. So that I found that really inspiring.
Dealing with the manufacturing going east, it has. It's gone, you can actually trace it sort of Eastern Europe into China, back through India, and actually it's coming back because we're seeing it's coming full circle, because the advantages of moving it have actually gone away, so increased wages and things like that, they've levelled themselves out, and it comes back and we have better quality, essentially, is at the moment. What inspires me? Well, on my office I have a very famous saying: it isn't easy being green, Kermit the Frog 1974, and that's actually what hangs on my office door.
Very good.
What inspires me, you might have guessed from earlier, was Bloodhound. I found very inspiring. But I think that, for me, I think it's just illustrated today that, you know, engineering and technology really can help to solve today's real-world problems. And I think that's really exciting. And I just wanted to come back to the point about the young generation and children, and whether or not children are great innovators. But you know what the thing about children is? They grow up into the great adult engineers and technologists of the future. And then they can really deliver and really use both their inspiration that they had when they were children, coupled with their experience then of being adults in the real world. And I think that's why we've really got to inspire the next generation of young technologists, because they will become the next great engineers and the next Brian Coxes of engineering, rather than just science for the future.